Good afternoon, everyone, and welcome to our webinar this afternoon. I'm Lynn Katz-Cherry from the Great Lakes Green Chemistry Network with Clinton Boyd from the Michigan Green Chemistry Clearinghouse, and we're very pleased to have you with us for our webinar, How Perspectives of Green Chemistry Will Drive Implementation, with Lynn Leger, the director of ALCERECO. So today we are very excited to have this presentation. It's a little different than some of our earlier presentations, and I think you're going to find it extremely interesting. Our presenter today is Lynn Leger, the director of ALCERECO, and after completing her degree in chemistry and an MBA, Lynn joined DuPont's automotive coatings business, where she held a variety of business, marketing, and technical positions. You'll see that she's had a lot of experience in a number of different areas, which has really given her the background to really talk about our subject today. She changed market focus and led new initiatives in food safety for DuPont, including responsibility for leading major R&D initiatives in breakthrough disinfection technology. She joined Green Center Canada in 2010 as a director of commercial development and worked with universities across Canada to commercialize greener technologies. She's the named inventor on 13 patent applications in technologies representing each of the different businesses with which she has been associated. She's a frequent speaker on innovation in green chemistry, including chairing a session on commercialization of green chemistry at the American Chemical Society's Green Chemistry Institute meeting this summer. She's currently starting a new business, ALCERECO, that will develop and commercialize new advanced materials in a number of markets. So it's with great pleasure that I turn the webinar over to Lynn Leger. Thank you very much, Lynn.
Great. Thank you very much, Lynn, as well, and thank you, Clinton. I'm going to get started, and what I'm really hoping to do today is to get people thinking and talking about what are the factors that it takes to successfully get green chemistry to marketplace. And I will tell you a bit of my bias for definition of green chemistry right now. By my definition, green chemistry must have an impact beyond the R&D lab in order to be able to be called green chemistry. You can be interesting chemistry, you can be relevant chemistry, you can be really important chemistry, but to be green chemistry, you have to be able to have an impact on society and the environment. And in order to do that, it usually means you have to successfully commercialize a product or a process in a company. So I'm going to focus on the route of getting to market and what it takes to get green chemistry processes and products successfully to marketplace. So that is the core question that we're going to be asking. And perhaps before I start, I'd like to ask you personally to kind of think in your mind, what is it that you think it takes to be successfully accelerating the commercialization of green chemistry? In the last number of years, I've attended a lot of green chemistry conferences, and I find that that's a question that gets asked in the hallways, sometimes in the bar after the conference. There's a sense of what will it take in order to move and advance and make green chemistry happen sooner rather than later. So that's a question that I found rather intriguing, because as you ask it and talk to more and more people, what you find is people have different answers to that question, and often very strong opinions about what it takes. They also, I noticed, tended to be things that were related to their own particular area of what they did. So researchers in universities would say you need more money and more research going into green chemistry. Educators in universities would tend to say, well, you need to have more of our students understanding green chemistry when they come out. And it was rather fascinating, the range of answers that you get, and they tended to reflect people's biases. So Lynn was asking me earlier what was the origin of this work that I'm about to show you. And it really was the question of what are the perceptions that people have around green chemistry and what it takes to successfully commercialize it, and what's the range of those perceptions, because people will tend to act upon their perception. So if you believe that more R&D is needed, and you may be right, that's where you will tend to say the answer lies. But I think what you'll see, and I'm hoping that you'll think about as we go through the webinar, is maybe it's not quite as simple as a simple one answer fits all. So just to shake up your perceptions a little bit, I'm putting a little bit of art quotations and perceptions here. And it's interesting to say perception versus reality. Da Vinci's quote is, all of our knowledge has its origin in our perception. So what are our perceptions? If you look at the picture of Vincent van Gogh, the photograph of the place he painted, I'm not sure that if you were presented those two pictures, you would necessarily group them together. I mean, structurally there's similarities, but how Van Gogh perceived something is different than another painter would paint that same scene. What I'm going to put forward to you is that people's perceptions of how to advance green chemistry are a bit like this Van Gogh painting. We tend to view things through our own lenses. And if we're going to truly advance the commercialization of green chemistry, I think we have to accept that the person that we're talking to may not share that same perception as you do. So let's take a look. What we did, and the results were first presented at the American Chemical Society session, is we went out to green chemists and we went to basically the mailing list of the American Chemical Society Green Chemistry mailing list, a fairly large list, and we had a good response rate. To be representative, I was looking for about a 5% response rate. We had over 50 people respond, and they took time to put in a lot of thought and text in their responses. So the response rate was actually excellent, and I think that the answers are fairly representative of what you'll see people who associate themselves with green chemistry believe is the case. So I'm going to go through a series of questions. The one you see on your screen right now is probably the single most important one that I'm going to go through. We sent the survey out in May, and we had people respond to this simple question: what factors do you believe are the most important drivers for the adoption of green chemistry in the next 10 years? And we allowed people to choose 3 responses, and we allowed them to write in responses if they didn't like any of the ones that were preset. So what you'll see there is regulation, better training for chemists was one of the top 2, consumer awareness, development of innovative new products, government incentives, increased R&D investment, transparent reporting requirements, cost savings, new manufacturing technologies, faster regulatory approvals, widespread use of better assessment tools, senior management commitment, and the other. What fascinated me was how spread out the responses were. And I will comment, because I'm not going to show a slide to this effect, that the people responding to this survey were not just academics. The actual largest number of responses came from people in industry. There were a lot of academics as well, but industry was actually more representative among the sample that was responding than any other group. So cost savings and better training for chemists came out as the number 1 and 2, which is fascinating because some of the things that you might select, and certainly I've heard defended loudly in some of those hallway conversations, didn't really register among the top 3 responses for most people. So you look at regulations, and yes, they're there, but I've had people adamantly defend the idea of if we just put regulations in place, green chemistry would move much, much faster. I've equally had people adamantly defend the idea that senior management commitment is the key to the whole thing. Nothing else really matters as much as that. But it was rather fascinating to see cost savings and the better training for chemists. coming out as the 2. Having said that, the other thing about the distribution that really struck me is you have to do all these things really well. That there isn't a one simple answer that says if we just do this one thing, then green chemistry will be proliferating at a phenomenal new rate. And that really kind of struck me as the range of things that you have to do to change the approaches that we take if we want to increase the rate of commercialization of green chemistry. In the session that I gave in June, I went through charts like this about people's perception, but then we wanted to challenge perception, so I had 6 companies come and present success stories, and what we tried to do in the session was look at it and say, based on the success stories, what were the factors that allowed this to be a commercial success? I've got a couple of slides from 3 of those presentations at the end, but keep these factors in mind that I'm showing on this chart and see if you share some of the same conclusions that we had once we listened in the whole session to what were the things that actually made a difference to the success stories. So the challenging perceptions we also challenged with success stories. So the other thing I will point out is on the chart, it says that the person sitting next to you probably would pick a different 3 than you would. And that makes for an interesting conversation with people. If you know in the back of your mind that the person beside you probably is thinking that 3 other things are more important than you are, that drives your conversation and can often help you understand where they're coming from a little bit better. So let's move on. Because I had people's attention, I used the survey to test a few common perceptions. And the one that I most enjoyed testing, perhaps, is on this slide. I asked the question, does the introduction of green chemistry generally lead to a higher price for the customer? Fascinating question, because I've heard people adamantly defend both sides on this one. Now, I will point out the bias here. This is asking green chemists, people who are on a list for the American Chemical Society as being identified in having a place in green chemistry. So this is what people who are the most knowledgeable about green chemistry believe. And to me, the good news is roughly 2/3 believe that green chemistry will not lead to a higher price. The bad news is 1/3 of people associated with green chemistry still believe that it requires the customer to pay a higher price in order to get green chemistry. That is a bit concerning to me, is that still at this point, people with the most knowledge in this field still believe that it's going to require higher pricing. What you'll see in the success stories is basically higher pricing is not an automatic, and if anything, sometimes it goes the other way, that green chemistry can lead to lower cost solutions and not necessarily lead to higher costs and higher prices. So this is an interesting one to think about, is if the people in green chemistry believe, 1/3 of them, that green chemistry leads to higher prices, what do we expect people without the training and the expertise of this group to believe? So let's move on and see what else some of the perceptions are. Regulations, a really nice broad word, regulation. And often you hear people say, well, let's just put in place regulations. So the chart's a little bit wordy, but I'll go through a couple of the key points. Is we wanted to say, well, yes, but there's a lot of ways to do regulation. What approach in regulations would actually have the most impact? And what we found, perception-wise, is if you could use expedited approval, getting approvals to commercialize a product faster because you have life cycle analysis, because you're using green chemistry principles, that actually was believed by the participants to have the strongest positive impact, if I look at the top 2 categories being somewhat positive and strong positive impact on advancing green chemistry. If you look at the red circle in the middle, putting penalties and taxes, and I can tell you there's a lot of people out there in the hallways who believe that that's the way to go. That was actually not anywhere near as productive as the idea of give me an advantage in terms of getting the approvals. The penalty approach, the stick versus the carrot, was not seen as being as positive to advancing the case of green chemistry. The fourth and fifth items on that chart were rather an interesting comparison. Do I go for regulations approach where I look at major change but give people a longer time to get that innovation? Or do I do a small incremental step more frequently? That's an interesting question, and I would love actually for an academic to study cases and look at which one actually works well. But the perception was evenly split. I had pretty much a pretty even split, maybe a slight more positive towards significant innovation over a longer time versus small baby steps as being a more positive. And then last but not least, the minimum standard approach, where I just set a minimum standard and do nothing other than that. If anything, that was viewed as having a somewhat negative impact on moving forward with green chemistry. So it's rather interesting when you ask the question about regulations of how do you structure them, what kind? And this started to give us a sense of people's feedback and perception. The next slide started to look at, will I make more money as a company? Because fundamentally, businesses are there to make money and get a return on their investment. If I put R&D into greener approaches versus standard approaches. And what we found, and again, this is an audience that is all involved in green chemistry, we found that, yes, there was a belief that I would actually make more money by going after green chemistry approaches than I would using the standard approaches. Only, 10% people thought actually that I'd make less money overall by putting my investments into green chemistry. So 90% thought I would do better or no difference by taking a green chemistry approach. I think that's a pretty positive statement because fundamentally what we're talking about here is commercializing. And commercializing has to do with, am I going to make money as a company by doing this approach? So if you can show people that green chemistry is a route to making more money, that is a very positive way of moving forward on the commercialization. The next slide looked at, and I'm sorry some of the text got cut off in the chart, so the answer choices are printed below. A rather interesting other question is there greater potential by taking an existing product and rethinking the process and the manufacturing process with greener approaches? Or are you going to have the best impact by developing new products for the marketplace? And interestingly enough, this group thought 2/3 viewed that restructuring and redesigning existing processes, but not necessarily changing the product at all, was actually the fastest way to have potential impact. And it's a fun question to debate, but it was interesting to see where this group came out on it. Sorry, I went backwards the other way. So where is R&D taking place right now, and where should it be taking place to accelerate the adoption of green chemistry? Possibly the single strongest, most positive answer in the entire survey basically said that industrial research versus university or government research would have the greatest impact in accelerating the adoption of green chemistry. If I had to pick one question that was as close to unanimous as possible in the survey, this is it. So then we asked the question, well, where is the majority of green chemistry R&D taking place? And admittedly, we did have large companies and small businesses broken out, largely because the small businesses tend to be more entrepreneurial, although coming from a large company, I could debate that and have an interesting discussion. But it does say that there's quite a bit of university research that we need to connect to that industrial research. I didn't want to necessarily judge this one, but I just wanted to highlight what are people thinking and believing in this survey. Now, the last question is, where are we going to find the entrepreneurs, intrapreneurs of the future that will really advance the case for green chemistry? And what we did was we said, are we better off taking business leaders and teaching them more about sustainability and green chemistry? Are we better off taking green chemists and maybe even as part of their curriculum in school, giving them a little bit of a business perspective? Or should we be looking at a much more cross-disciplinary training in general? And that was viewed very strongly by people. There were people who supported each view, but generally that cross-disciplinary. And for the academics, I would leave that as a rather interesting question to go forward, is are we really designing the curriculums to allow green chemistry to be successful in the marketplace if we don't consider this cross-disciplinary piece that is necessary to get from the lab into the marketplace? I don't really know the answer to it, but I like to leave that one out as a question on the table for people. This question is a lot of fun, and I promise you I'm not going to go through this slide in detail. But I did ask the question of what are the most important types of research that need to be taking place now to support a future based on green chemistry principles. And I have to admit, the most fascinating part of this question was of, I think, 54 people who took the survey overall, I believe 50 of them, phenomenally high rate, took the time, and this is the last question on the survey, to type. And I'm just showing you fragments of many of the answers, typical answers. I had people writing paragraphs and paragraphs of what they believed needed to be the case. Just based on the response rate, I would say this was a question that evoked phenomenal participation and emotion among the supporters here. So a key look at this, it really covers a wide range of different aspects of green chemistry. We have people talking about policy research. We have people talking about energy and the importance of green chemistry to energy. We have people talking about better understanding of toxicology, life cycle analysis, biomimicry, diversifying away from oil-based chemistry. Really, really strong and, like I said, sometimes very, very detailed answers. It's a very passionate community that are looking at what types of research need to be taking place in order to advance green chemistry. It isn't one single answer. There's a lot of things that need to happen, but the good news is there's a lot of passion out there in the community for this type of research to take place. So this was essentially the first session in our session at the American Chemical Society, was saying, here I'm putting on the table without trying to judge whether there are people who are right or wrong, but here's what people who are involved in green chemistry believe. Here's what their perceptions are. Here's the way they see the painting, like we had in that earlier slide by Van Gogh. And not everybody sees it the same way. So now we wanted to challenge and say, well, let's look at some real success stories and challenge those perceptions. So I don't have time because this is a several-hour session, but I picked out a few key slides that I'll share with you that some of the other presenters who were talking about success stories talked about. And I'll talk about some of the things that I saw as they started to talk, coming through in comments, and I will admit that some of them changed my perception by the end of the seminar. One of the first presenters was Ecolab. And Ecolab, for those of you who are not aware of what they do a lot of industrial cleaning products. And I'm showing this slide because the presenter from Ecolab basically got up and talked a lot about their corporate commitment to sustainability. And an interesting thing is, I didn't tell them to do this, but every single industrial presenter who got up and was asked to present on green chemistry, every single one of them called it sustainability. None of them spoke of it as green chemistry. And just as a hint, if you're dealing with industry on green chemistry, you may actually get much more of a recognition of what you're trying to do if you use the language that they use, which in this case is sustainability. So when you see sustainability from a corporation, they consider green chemistry to be part of it, but sustainability is the larger concept that holds green chemistry. One interesting part of this slide is earlier on in the chart, we saw corporate commitment and senior management commitment. Most of the companies got up and showed how their company was committed to sustainability. And this is just one example where they have metrics, the EROI, delivering environmental and economic improvement, And Ecolab actually has a whole report every year with measurements and metrics. And trust me, in business, if things aren't measured, they typically aren't focused upon. So that was an interesting observation as we saw that coming through all the different presentations, this idea of measurements, corporate commitments before they talked about their products. The project that Ecolab presented, and again, I'm not going to go through it in detail, and I believe most of the individual presentations are actually on the American Chemical Society website, is they were doing hard surface cleaners for a particular market segment. I don't want to go through it here, but I point out a couple of things. They did get some investment from a government fund, $52,000. That, however, is a small amount relative to the cost of developing a brand new product. Nevertheless, it was a nice little incentive or an accelerator for them to get going. But what they talked about was focusing on the performance of the product and the project renewables. So they wanted it to be green chemistry, but they would not, and you'll see that in the customer driver, they would not sacrifice efficacy for their customers. And they had perceptions among their own that cleaning products are harsh and unsafe that they wanted to deal with. So let me show you one thing that really stood out, and this became a common theme. They reformulated, they used a lot of biosourced materials, and in the end, not only did they not sacrifice, but they came up with a more effective product that outperformed the benchmarks on their testing. That was a theme amongst all 6 of them, is if you do not have the performance, it doesn't matter that it's green. It needs to perform, as any product does. So that came out loud and clear, and I thought this chart really highlighted it, is not only did they manage to meet their desire for a bio-based material, but they actually successfully made a better product using green chemistry. The next one was Tremco. So we had industrial people here talking to people who were in the consumer market, who were industrial processes, and who were in very different markets. We wanted to see how green chemistry went across. So Tremco talked a lot again about integrating sustainability. There's that word instead of green chemistry again, but really arriving at green chemistry is part of that process. So Tremco talked about a number of examples in their presentation, but I wanted to show 2 slides quickly out of their presentation. This one had to do with process excellence. So remember the question, are you going to have a bigger bang for the buck if you go with greening a process versus new products? And as part of their Lean Six Sigma and their reduced energy and cycle time initiative, things you typically do in a business, in an operation, they wanted to reduce solvent, a very green goal. And they actually reduced their solvent for this particular process by 90%. So that's an excellent example of green chemistry in action in processes by looking at solvent use and reformulating solvent. Simultaneously, they looked at their product development portfolio, the things they were putting in their market for their customers, and they've talked about short and long-term opportunities for products they had developed and they were going to be developing that were part of a plan and part of a strategy for a greener, more sustainable portfolio. And again, that very strong commitment to the measurements they had in the organization. They weren't doing this because regulations. Well, the regulations have hit that industry hard over the last number of years for VOCs, et cetera. They were doing it because they wanted to deliver better products to their customers. So green chemistry for them was a route to do that. Sometimes these slides are as instructive for what you don't see as for what you do see. And let me go down to the next one. Dow Chemical was one of the next ones. And I wanted to show one of their metrics. So again, the theme came out of sustainability and metrics and business commitment. They have a commitment to increase the percentage of sales of their products that are highly basically advantaged by sustainable chemistry. And they have all kinds of indices and all kinds of measurements and toolboxes and training. It was rather fascinating to hear Dow talk about the things that had changed their culture more and more towards sustainable chemistry. And they put up a number of examples of new products that were driven by that and new processes. But I've picked out one just to share with you quickly. And that is looking at a heat transfer fluid, Galtherm. And basically that's in conjunction with some of their projects around solar heat energy and what they have with this geothermal product and concentrating solar power, and they have basically done it in Spain, is basically they've built a number of plants that use this heat transfer fluid, and the energy produced in these plants is enough to power 400,000 homes. So having this heat transfer fluid and combining it with solar panels, they have basically prevented about 1.5 million tons of CO2 from releasing into the atmosphere versus traditional fuel. So there were a number of themes that came out over all the 6 different presentations. And like I said, I was just picking a couple to show you as part of this presentation. But it really is diverse. So you'll have a lot of people who think, well, sustainability is all about carbon dioxide. And here the Dow example addresses that, but that isn't the case for many of the other ones. You'll have people talking about it as being about toxicity. It really spans a wide range. And the couple more slides I'll show you from the other presenter talks more about the toxicity side and the performance side. Being a green product. However, the minute the recession hit, the sales almost went down in half. And one of the reasons that the presenter focused on is they had charged a price premium, not because it cost more, but because they felt that they were going to market it with a price premium. And they basically paid a price for that, that when the recession hit, people stopped being willing to pay that price premium, stopped thinking of it as new and cool, and just saw it as expensive. And what you're seeing is right now, in 2013, Clorox is repositioning this product line and getting rid of the price premium and almost relaunching these products as fully competitive, good performers, and not with the price premium. SC Johnson has products out there as well and is very committed to greener chemistry. I just want to point out one thing on this slide. Is sometimes it's not good enough to have the chemistry. You really have to hold the whole package. And you'll see the Smart Twist cleaner there. Sometimes the different chemistries will come as 2-part chemistries rather than a 1-part. And I worked on one myself, which makes me really sensitive to this particular bottle. Is sometimes the bottle costs more than the contents. And if you have to redesign the application or redesign the way people do things, sometimes you need that to be a part of your green chemistry thinking, and your green chemistry product is, I need different dispensing, different ways of using green chemistry. So here's a great example where SC Johnson was willing to go the whole way and redesign the application for the consumer in order to make it possible to introduce some green chemistry. And last but not least, Lysol, a good example of that was introducing some hydrogen peroxide-based cleaners, much better carbon footprint, much better from a toxicology point of view, no residue, and it breaks down to water and oxygen. And yet all of these, I can tell you from the person who presented them, the critical thing that made a difference was performance, performance, performance. They are not going to put out a green product unless it achieves the performance goals and delivers performance to its customers. And as the GreenWorks Clorox project demonstrated, not performance at a premium, but having that price in line and delivering value as part of the performance piece. So it was a fascinating session that we had. It raised probably as many questions as it answered, but it left a lot of people thinking about their own perceptions of green chemistry and thinking through the examples they'd heard about what does it really take to advance green chemistry and move forward. And I'm hoping I've had a chance to share some of that with you today. And basically, I'm glad to take your questions, and I hope you enjoyed and were thought-provoked a little bit in what I've been talking about here. So I'll pass it back to you, Lynn, and thank you very much.
Thank you, Lynn. That was really very interesting. And we do have a couple of questions here. I wanted to take advantage of that, though, and ask you a question first, which is, how do you see your results kind of being operationalized? I mean, where do you see going with these data from here?
Good question, Lynn. I think they can be useful from a policy point of view. I actually, in Canada, sit on an advisory committee to the government that is looking at how do we introduce more bio-based products in the economy. And I think that these results have already impacted some of my thinking around the overall perspective of what it takes to commercialize things has to be taken into account. You can't just do the research and hope that it just falls into place. So I think from a policy point of view, I would hope from an education point of view, there were a lot of people who are responsible for green chemistry education sitting at this session and who contributed. And I think businesses as well. A lot of the businesses in the room had people swarming around them at the end, asking a lot about what does it take to change the culture and the policy so that green chemistry is just the way you do things rather than an exceptional project. So I think it can impact on multiple levels.
That kind of leads right into the question, the first question that we have, which is, do you support an ACS mandate that accredited institutions teach green chemistry courses to graduating students? If so, how would you propose that those of us who are interested make our voices heard? If not, why?
Well, an interesting question about that, because I've actually given lectures periodically in universities that give green chemistry, and I'll come in sometimes and give a class. I'm going to go back to the perception about the multidisciplinary approach. It's fine to go in and teach a lot of the technical, and that's absolutely necessary. But I would say if you're really going to teach green chemistry, you're going to have to start teaching some of the business side of it as well. And there are some schools that are really experimenting and doing some interesting things around exposing their business students to green chemistry and exposing their green chemists to business concepts. And it goes over really well. I'm actually going to be participating in September in a workshop where we're taking at that particular university 10 graduate green chemists and 10 MBA students and having them work jointly on a workshop case. And I'd love to see more of that interdisciplinary, cross-disciplinary as part of green chemistry. So I fully support it because I think it's not only important for the way we do things in the future, but I think it's also, as you saw from the return on investment, just a really good thing to do from the perspective of how does chemistry contribute to innovation in the economy.
Yeah, I know they're doing that at McGill, and we're really hoping to get a webinar on that because it's been a very successful program there, and it's a really, really interesting concept. So the next question is kind of goes back to what I was asking. It says, read a question on where is green chemistry research taking place. Results are based on respondents' perception. Has anyone actually quantified this to compare perception to reality?
I actually would love to see everything that I asked quantified, and there are a few researchers who were there, and some of them you know, like Kira and Steve from McGill, where I'm trying to put these slides in front of them and say, shouldn't some of the research going on tell me what the reality is and what's really happening? I'm just testing people's perceptions of what they think. But if you know of anybody who has taken any of the questions that I presented and actually done some quantitative research, I would love to see it. And I'm fully supportive in saying these are the questions we need to be answering.
Maybe somebody could do that. So another question, and this is one that comes up all the time, and I think it's a really key question, is how do people trust the greenness of a product? Is there a regulatory body specifically for such products? If not, will it be a good idea to have one? I'm afraid the word green can be used loosely.
I completely agree with you, and the reality is it's never an absolute, green being one thing and like a black and white. The reality is we should probably be using the word greener chemistry because it's like a continuum that you may take a bad process and make some aspect of it better. And you need to continually be moving and continuously improving the process, but there isn't an absolute threshold and it will vary by process. The reality is what you should really be doing is comparing a product and a process through life cycle analysis to the alternative. If I weren't doing this process, what would I be doing? And it's not easy because sometimes you may have to make trade-offs. You may achieve, for example, significant benefits in lowering the CO2 emissions in a process, but you may pay a price in terms of using something that is a more toxic raw material or something that's not recyclable. So rarely is it an absolute that says every aspect of this is greener. When you get to decisions about how you manufacture it, how it's used, how it's disposed of, you'll find there's always trade-offs. So it is very difficult. There are some out there who have tried to find ways to put checklists together, and I know that the ACS has been working for quite some time on checklists. And that is a good starting point, becoming aware of how you perform on the checklist relative to the alternatives for the customer.
Yeah, I mean, that's really been a very difficult issue to address because, you know, there have been multiple efforts, and right now the best that's kind of come up is that there are alternatives assessment that can look at, like you say, exactly comparative, something, what's greener than something else, or, you know, what has less inherent hazard than something, a chemical which is less hazardous than another chemical to serve the same purpose. And there are also certifications out there, you know, for products. You can be certified by Clean Ingredients or by Design for the Environment, and that's kind of the closest that we get to defining criteria. But part of the problem has been that nobody really wants to codify green chemistry because it's so dynamic, and if you set criteria this year, things may be changing by a year from now, and you can't really, and you don't want to stifle innovation and continuous improvement. So it's really a double-edged sword, I think, in a lot of ways. And that is always a question of how do you discern what's greenwashing from what's truly green. That's a great question.
Yeah. The other place I would look is product stewardship processes in some of the companies have started to deal with that question. Mm-hmm. So when I can speak for DuPont here, and what Dow was showing in the presentation in the session in June was somewhat similar. But product stewardship processes now require in those companies that before you commercialize a product, you have to go through a product stewardship review, and it will ask questions that relate to all the different dimensions of, are you generating waste? Have you looked at emissions? Have you looked at toxicology? Can you dispose of the packaging? How will your customer use the product? And I can tell you at DuPont, your answers had better be satisfactory, or you do not get to launch the product regardless of how long you've worked on it. It has to be the sustainability goals of the company. So if he starts to embed more of that thinking in cultures and make it more of this is the way we do business, that's probably the best way. But it's hard for small companies to put that kind of systemic approach to that you see that the larger companies are starting to do. But many of the larger companies are also willing to share that knowledge because it's not a competitive advantage. It's just a way we should be doing business.
Right. I think that's exactly right, especially that when we talk about not having green chemistry anymore, but it just being the way chemistry is done, it being the way that product innovation is done, that these are the things that are taken into consideration when something new, when the whole process of product development occurs right from the beginning. And you know, and there are the Great Lakes Green Chemistry Network and the Institute for Agriculture and Trade Policy has actually been sponsoring workshops. We're going to be doing 2 workshops the rest of this year, which I was going to mention anyway, so this is a perfect opportunity. We have an upcoming workshop on October 8th in Rochester, New York, and then one on November 13th and 14th in Stevens Point, Wisconsin, and they're called Safe Products Made Safely, Tools for Business, Safer Products Made Safely. And what they are a set of tools for sustainability, which are sort of based on the principles of green chemistry, but they're tools for business to begin to do exactly the things that we've been talking about now. And they cover a spectrum from tools that help you look at the chemicals in your stream and determine whether there are less toxic alternatives, tools for life cycle analysis to figure out all the questions that you were just talking about in terms of product stewardship. That's what a life cycle analysis can address. And also tools and places to go for product certification. So I think that there's a growing awareness of that kind of that need, and that not all small companies can do that, but that there are external tools that are available for that kind of thing as well. And in our workshop, we not only try to you know, provide resources for companies about where to look for and find the tools that most suit them, but also to give them some criteria for judging those tools and really figuring out, you know, being able to ask the right questions to figure out if a tool is actually the kind of tool that they're looking for. And we thank you again for participating in today's webinar. We also thank Lynn so much for her terrific, terrific presentation. And we look forward to hearing from you all again next month. Thank you very much. Bye-bye, everyone.